Today we will discuss more, and we also do some real-time detections, okay, and some deployments. If possible, we'll do that. So that is the agenda for today's class. You can download the Anaconda software if possible, because today we are going to discuss about this Anaconda software. We call that as operating system for AI. Okay, we have lots of advantage by using Anaconda. Mostly we used Google Colab. The reason is we no need to install the library function. Okay, so just we can, if you connect your notebook with the server, then you can use the library from the Google Colab server. But here we have to install every library function. Then only we can able to work on the coding. This is common for any IDE. For example, this is one thing Anaconda, and we have a PyCharm is there. That is also one of the popular IDE. And beside that, Anaconda, you have a Jupyter notebook, Spider. There are lots of things. Okay, I will explain all those things. If possible, you can download it and install on your Windows. If you are using Windows, download it. And if you are using Linux or Mac OS also, you can install that. And one more thing is, why you have to learn this means for real-time applications, if you use this IDE, it will be very useful for you. For study purpose, for learning purpose, still Google Colab is the best one. Okay, so if you click this one, you can have a free download is there. You can download it for free. Okay, I already downloaded that. When you scroll down, you have all the options. So we are interested in the, if you are using Windows means you can use the Windows option. Okay, this is the place where you can download it. Okay, installing on Windows, just directly you can go Anaconda install for Windows. If you click that, .exe file will be downloaded. It is asking sign in. If you are already registered, no problem. It is asking some verification code and all. Okay, just go through it and download. If you are not used on, okay, just install it. All the things will be given. How to install, everything will be there. Just register and download it. That's all. Normal one. No complication at all. Okay, so everything will be there. Is anyone using Anaconda software on your system? If you are using means you can follow the steps what I am doing. Otherwise, you can just watch and enjoy. Okay, if possible, you can do it afterwards. Just go to this link and then download. That's all. Okay. I'm waiting for your response. Is there anyone already installed Anaconda? Okay. Okay, Siddiq sir is using. Okay, others try to download, register and download. If you have any doubt, I will do it slowly because you have to follow the steps. So once you install the Anaconda on your system, you will have a Anaconda navigator. Can you see on the screen? You will have a Anaconda navigator in your system. It is available. Okay, in that, if you go to open, it is a big unit. Your system should handle it. Okay, so once you open it, you will have a windows like this. Can you see this? In that you have home. In home you have lots of toolbox IDs. So I already told PyCharm is another one. You can download it, and Spider is another one. VS Code is there. Okay, so there is lots of IDs here. Jupyter Lab, Jupyter Notebook, okay, RStudio. So these are the things that you can use, but you have to launch or install these programs. And the interesting part, the thing you have to understand is environment. Go to the environment. You have base root initially. After installing the Anaconda Navigator, you will have this home page. Okay, some of the thing you need to launch, okay, or install, you can click and launch it. That's a thing. And then in the environment, you will have only one thing, that is base root. Okay, so this base root contains some of the basic libraries that is already installed in the Anaconda Navigator. Okay, but what we have to do is you have to create a environment for yourself. For example, if you are doing machine learning, means create one environment for machine learning. Okay, so I already created. How to create it is here like this. I am just creating one. This machine I am putting. Here it is asking what type of Python. 3.11.9 packages. So this is the thing. Okay, you can just create it. If you don't have the Python on your system, it will ask while installation. Then you can install that also. Otherwise, you can download the Python from the web and you can install it. So if you put Python IDE, you will have. Okay, you can download it from here. Python.org. Okay. Otherwise, you just create it. If you create it, you can see another environment is created. This environment is fresh, doesn't have any library functions inside it because we are only creating. After that, we have to install one by one all the libraries that we have to install. Once you have installed all the libraries, then you can able to work on the machine learning, deep learning, all the programs you can directly execute on this. So how to install the library is, okay, so just click on this play button. Okay, it will take some time to run because this is not a small software. Okay, you have open terminal here. Can you see the open terminal? If you click the open terminal, uh, you have a command window. Okay, so here machine learning is the environment that is stored in the location users hashboard. So this is uh, the location in the system. Okay, where the library is going to be stored. Okay, so here you have to type all the things. I will tell you how to do that. First, I will do pip list. Okay, just to show what are the library functions that I have installed in my Anaconda. Okay, can you see here? Some of the things are stored. The libraries are automatically library functions will be updated here. But most of the things like here you can see uh, the most popularly used is scikit-learn, right? So this is the scikit-learn, okay, that I included in this library. And then what is that? Tensors I didn't install it. This is for machine learning. So I've installed all the library functions that is needed for me. Okay, pickle I installed, numpy I installed. Okay, OpenCV I've installed, pandas I've installed. So these are the library functions that we used in the programs. Okay, this okay. So that's the first step. How to install it? Okay, just open the file that I sent to you. Just open the file that I sent to you. In that we have a camera. Am I right? So you have one file called camera. I have sent three files to you. This face detection. Inside the face detection, you have camera and we have a R cascade frontal face code. Okay. And another one is YOLO I sent. This YOLO you have one Python file and you have a source file for this or library file for this YOLO. Okay. First I will explain this one. Okay. Now you can see the so this is the file I opened. This camera is the file that I sent to you. I'm closing everything here. If I want to open it, unzip the folder and then go to the location where you have stored. Okay. And then from here, I'm interested in the face detection. If you go to that Python file will be there and just open it. When you open it, this will be open. So what I'm using is I'm using the spider. Okay. Where the spider is in the home, you have a spider here. Okay. So if you click launch, if you click a launch here, you will have a screen like this. Okay. If I close it here completely for your convenient, so just go to home and then launch. It will be opened. This is an environment. Okay. So in that only I'm opening, go to the file and open the Python file on this. So this is the area you can work on the Python. So we have a program. Already we have discussed all the concepts. So that's why mostly it is a discussion part. Import CV2. This is the library for computer vision. And we have a face detector variable and a cascade classifier we're using, and we are calling the file R cascade frontal face default.xml. Where this is, it is also inside your folder. In the face detection, you have R cascade frontal face default. Okay. So this is the XML file. Copy the location of that. Copy as a path, because if you run, either you can copy the path or you can keep these two in a single folder. You can see I will keep the code as well as the XML file on the same folder. If you keep both the things on the same folder, you don't need to give the path. You can give the name. That's enough. Okay. What I have done here. So I gave the name alone. R cascade frontal face default .xml file. Okay. If it is in different location, then you can give the path here. Okay. And video capture. So this is the command you have to learn. CV2 dot video capture 0. When it is 0 means the camera that is connected with your system will be detected. When you give video capture equal to 1, then external camera, if you are connected with your system, that will detect the external camera. That is this purpose. And then while true, return frame, so it will capture, the camera will read. Okay, video capture is the camera will read. Okay, and then it will resize the frame to 600 comma 400, because the frame size will be anything, isn't it? It may be a huge one, it may be out of your screen, so that we have to fix a frame for, then we can able to view it. Okay, and then image gray, again yesterday we have discussed in the computer vision, CV to convert color, that means you are converting the image, the resized frame into the grayscale image, because we are going to detect the face using this. And then directions, face detector dot detect multiscale. So it's already, this code we have discussed yesterday. So I'm just running over there. So we have fixed some min size and fixed some neighbors. Okay, if you want to change, you can change it. You can play with the parameters. Yesterday, we played a lot, isn't it? And then I'm converting the identifications from the I am converting the detections into a rectangular shaped frame. So how I am going to do is x comma y wh, we are putting that in the for loop, and then I'm creating a rectangle and green, and then this is the width of the border of the rectangle. And finally, I will show that on the video, and then this is the key. So CV2 wait key 30 seconds, and then if you press press Q on the keyboard, the screen will break. Okay, the video capture will release. That means the camera will not capture the image anymore. And then CV2 dot destroy all the windows. All the back running files will be destroyed. So this is a simple program that we are using. Okay, so if you installed your Anaconda and then the spider, then you can run this. Okay, when you run this, your face will be detected. Okay, real time face will be detected. If you have a camera, then you can see. You can see it now. I am running the camera, so the camera sees the picture. Okay, so when I bring my cell phone close to that, you can see the faces is detected. Okay, it is a real time capturing. If you give any other photos for that, it will be again it will capture them. Okay, so that is one of the example. If I press Q, the camera is off. Okay, so you can work on that. So this is one interesting real time applications that we can do using that. Okay, you can pose the question: grayscale or black white binary is better? Okay, so we are not using black and white in this. Either we are using grayscale or color image. Black and white does not have so much of information. Okay. So either grayscale or color image. The next thing is YOLO. I have another program called YOLO. Just we go to the YOLO one. That is also very interesting. How many of you heard about YOLO? What about the library used in Spider install? Okay, very good question. Since I have installed all the library function, I didn't mention that. If I don't have a library function, okay, when I run this program, it will put a error here. You can see some error. Okay, but here it is not showing any error. Okay, the reason is I have installed all the computer vision. Uh, Only one library we are using here, that is CV2. Already I have installed that library. How to install that library? Go to Google. Okay, pip install CV2. So that is the library I need. So if I use pip install CV2, you have pypy.org is there. And then if you click on that, you will have pip install OpenCV Python. This is one way. Another one is whatever the library you want, put pypi and give the name CV2. You will have another way. Okay. Otherwise, pip install open CV2. You will have OpenCV Python. So here you can see pip install OpenCV Python. Just copy it. Okay, and then go to the Anaconda and to your environment. So this is my environment. So already I've installed here. So I'm not going to show here. Anyway, I will show you from this place itself because, and then I'm going to copy and paste it here. When I paste it here, pip install OpenCV Python, just enter. It's saying that requirement already satisfied. It is there in your system. If it is not there, it will install in your system. Can you understand this? Okay, this is the way you have to install all the libraries, the required libraries in your environment. Once you install that, you can use that on the library, on the Spider. Okay, so that is the way to do that. Another thing is YOLO. This is one of the interesting algorithm. Mainly, they are used this for object detections. Okay, so I'm just open that YOLO from the YOLO folder. YOLO. Okay, so where this YOLO is from the Ultralytics. Okay, so copy that Ultralytics and go to your browser. I already told PYPI Ultralytics. Okay, you have that. Okay. And then you copy that and go to Anaconda and go to Open Terminal and paste over it. and then enter, saying downloading all the automatic things. Okay, and then it is taking some time. Okay, so this is how it will install the programs. If it's saying some error, means there may be a mismatch in the versions of library. Okay, that we have to put it on the chat GPT and find out what is the real problem in the versions. Try to solve it, but you have to install it like this. There is no other way. Whereas in the Google Colab, it is not the thing. Just one click, you can connect the library function. Okay, now I have done that. After that, CV2 I already done. Math is the another library function. Okay, so these are the library functions that they are things. Okay, after that, cap CV2.video capture. Again, the same thing. Refers to the default webcam. Okay, YOLO means you only look once model. If not, cap is opened. That means that there is some cap on the webcam, isn't it? Okay. If the cap is not open, it will show that printer and then exit and then cap set. We are going to again set the uh, width and height of the frame size of the camera, 640 to 480 pixels. And this is the YOLO. YOLO8 is there as well as YOLO5 is there. You can use any model for detecting. I will use to these things. You just take out the hash and you can use YOLO5 also. And these are the class names. Okay. That means this YOLO5 is trained with all the objects, most of the objects. So that's the lots of versions are there in YOLO. And I have given some of the class names here. If you show that image, it will be detected and it will say that this is a bicycle, this is a car. It gives the name also. It does the detection as well as the recognition. Okay. And then while true, again, what you're going to do is, if not success, if the camera is not detected, it will show that cannot read the frame from the webcam, and then the result will be sent. Or when you detect the camera, you have to fix the bounding box. In face detection, you have only one thing you have to detect, that is the face. But in the YOLO, you are going to detect different kinds of objects. For that, different types of bounding box you have to fix. That is also variable one. You should not have a fixed one here. Okay, like X, W, Y, H, there's some value. No, not like that. We have a integer values that is based on the uh, objects here. If the carrot, if you take, it will be somewhat rectangle. Okay, if you take TV, it should be square. So like that, the bounding box will vary. I will show that in the real time. After that, we put that in rectangle. We are making the shape for that with these coordinates. And then confidence. What is that confidence? Means how much confident your detection is. Because since you're going to detect multiple things, car, bicycle, person, many things you are going to detect, means something may be mismatched, isn't it? Instead of car, it is showing something else as a car. So for that, you should have some confidence level. Okay. So that confidence level is also mentioned on the detection, as well as the class names. Already we have mentioned some of the class names here. It will show that names in the detection. And then the font size of that one is, we are making the font size as 0.5, and the font is some Ashley strings like that. And then yeah, what it will be there means the image. In the image, you have the class name and the font scale, color of the image. Everything we are mentioning that. Okay, thickness is 2, color is I think red, font size, font, and then the origin of that. Okay, everything, and then finally webcam, and when I press Q, everything will be released. So this is another interesting example. After doing this, just run the program again. Okay. When I run, if there is no error here, that means all the files were installed and there will be no error on the code. Okay, now it is taking some time. Okay, and then it says there is no webcam. Okay, so we have to check what is the problem. Okay, I am so there is lots of thing. Okay, I will show with different images. Just opening the webcam, and then I am showing. So yes, you can see when I sh- when I show the different things. Okay, okay. Just I'm so it is not uh, showing the correct things because we are not given the name. So for screen and all, we are not given the name. So for cow, dog, we have the classes. So I'm using my so I'll show the cell phone here. It detecting as cell phone. Am I right? And then by detecting my hands, it says person. Okay. When I move the cell phone closer to that, okay, there is an image in it. Cell phone person is showing. If I show mouse, let's check it is detected or not. And I'm showing the pen. It's showing as toothbrush. Okay. You can see the confidence level of that on the uh, console. Okay. Now you can see it shows as bottle. Okay, something is detecting as bottle. Okay. Like that, you can do all the detection, all kinds of detection using YOLO. It is already pre-trained. So that's another interesting applications. So all these are real time. Now we move to another one. So another thing is very interesting one. Um, the first step is I'm going to go to collab. Okay. So this is diabetes model prediction uh, data set. In the data set itself, you have a data set for that. Okay. So we know these things. First, we have to connect the Google Colab with the notebook. See here also you are using the 9.5 pandas, sklearn, everything, but we are not installing that directly. So it is by default. But when you are connecting your notebook with the server, these libraries are all getting installed, connected to this notebook very easily. So first upload the data set diabetes. Okay, and then just run this one. The NumPy for array handling, pandas for tables, CSS file handling, and sklearn. It contains all the algorithms and models. Here, the model selection is train test split for splitting the test data and the train data from your data set. And sklearn, what you are using, SVM, support vector machine algorithm that we are using. And finally, metrics and accuracy score. So these are the library functions. By clicking this button, all these are installed on your notebook. Okay, so that's how easy when you are doing with Google Colab. If you are using Anaconda, means you have to install one by one into that Anaconda, and then you can use it. One time you have to do that. Not you should not repeat that again and again. Okay, if you install that once in your system, then you can use it. Okay, the next thing is connecting the data set with your diabetes. These are I have repeated many times. I'm just running this because the concept here is not this one. The concept is deployment. So here, this is your data set. You have the pregnancies, okay, the 0, 8, like that. The pregnancies is there. Okay, I think this is a month. It's representing the month, I think, and this is the glucose level at the time, and is the blood pressure, I think. Okay, level, and then skin thickness. Also another parameter to determine the diabetes. And this is the insulin level and the body mass index and diabetes pedigree. Okay, how much they can have this diabetes, and then that they are having the diabetes or not. If it is 1, they are having diabetes. If it is 0, they are not having diabetes. So this is the data set that we have, and we are going to use the support vector machines. Okay, you see that there is 768 data, and if you want to describe means all those things you can describe. You can just run over it, and then the outcome. How many patients in the data set have a diabetes, and how many of them have not the diabetes. Okay, zero is non-diabetic, one is diabetic, and then we have to group by. So these are the things, normal things. Okay, the mean value to find the mean value of that. So this means in the outcome zero, the pregnancy is three, around three. In the diabetes, the average is four. Glucose level is 109. Average glucose level for the outcome one is 1. So like that, we have the parameters. Okay, with that's just they are analyzing the data, and then this data and outcome are taking this outcome as y. That is the independent variable. That is the dependent variable, and the x. The remaining things, all the remaining things. Here we have taken as all those things 1, 2, 3, 4, 5, 6, 7, 8 parameters. All these 8 parameters we are taken as dependent variables. Okay, and then we can print x and y. After that, and splitting 20% we are used for testing and 80% for training. You can see the size of that. Okay, S shape is 768, train is 640, and like that. And then we are using the training the model SVM, SVC kernel, linear, and then classifier, and then we are training. Okay, now the classifier is your model. Use the model for predicting. Okay, first thing is X-train prediction. So just for comparison they are doing. Okay, already we have trained that with X-train, and we are again taking the prediction value for that and seeing how much accuracy is there. And here also for testers. So this is the real accuracy, unknown data, and we are testing that with the model, and you can see it is around 77%. So it's good. And then we are giving some unknown data into it, and then it is predicting that as diabetic or non-diabetic. Okay, and this is the important thing that we have to notice here. You can see another library function called pickle. What this pickle is doing is it will convert your file into SAV format. Okay, okay. Pickle is one of the library. If you go to Google and type PY pickle, you will have a pickle library function. Okay, okay. So I will tell you what will happen. Okay, then we are creating a name called diabetes model dot sav. Okay, so this is the file name that we are I'm just running the pickle first. After that, pickle dot dump, what I'm doing is I am writing this classifier is the model. I'm writing this classifier on this file name diabetes model dot sav. Okay, so now your classifier is dumped into this file name using pickle. So that is the use of pickle library. Okay, when you are when you want to dump something in a file name, okay, you can do that. So that I'm loaded that pickle. Okay, I'm just opening that. I can read the file. So what is this sav means? You can, once you write it and you can dump it, means you cannot modify it. Okay, you can use that file as a model any applications anywhere without training, without the data set. You can use that. Okay, so that is the beauty of that. Okay, you can load the saved model. Okay, after dumping you can load. Now you can only read. Okay, read in bytes, write in bytes, WB means. And then I'm giving some data into this loaded model. Loaded model means what? This diabetes.sav, and then it will predict our values. So now you can see when I dump unloaded, you can see a diabetes model here. Can you see the diabetes model here in the sav.sav? It is stored in the .sav format. Okay, can you able to see it? Okay, so now this model you can use it anywhere as a model to find out the diabetes. Now you can see input data again we are sending. Where we are sending that input data is to the loaded model. Okay, we are not sending that to the classifier because that is loaded here. And then if you run this code, it will predict whether the person has diabetics or not. It is predicting. Okay, for column in X columns, print column. Okay, so that means all the things. Okay, here in the thing, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI will be a column has been in the post. So this is where this is the thing that you are going to use on the code. So now what we have done is we have converted a trained model into a file that is read only file. Okay, we have converted that. After that, you can copy the path or you can download it. Okay, just download it. Okay, when you download it, you can save that model anywhere you want. Okay, so you can create one folder and then you can save it. You can save that. So now this model you can use in the web or anywhere for predicting the diabetes. Like that, you can convert any machine learning into a read only file, and then you can use that for. Okay. So let's see how we are going to do this. Okay. So this is the thing I have sent in this one. Diabetes model.sav, and then diabetes public. I will tell you what is that, and then one more file I will send you, that is the requirement. So these are the requirements that is needed for developing the web app. So we are going to create one website for the model. So for that, these are the library functions. I have included the version. So you have to include the same version. Okay, I will tell you how to do that. Now go to the Anaconda. Okay, and then open the diabetes.public. Okay, in that, what are the library functions that you are using is first one is pickle. To find out the pickle is go to the web pickle. I already told PY pickle. Here we have pickle type. So copy that, go to the Windows and then paste it. It's already installed. Okay, it is showing the error. Okay, pickle.py is not showing. Okay. So something it will be like this. Okay, sometimes the version will not match. So in those cases, what you will do is pip install pickle. So this is another way of doing. So you will have some other thing you will get, and then you can install it. Pip install pickle. So some version, if it not supporting means you can try some other way. Okay, like that, go on, install it. So this is the thing. It will take some time. Okay, if you run it, it will take some time. It is showing that it is installed. Okay, so like that, you have to install all the required files. So that's what I mentioned here. Another thing is the library functions that is needed is because some versions the Python will not support. Some maybe in the latest version will be there, then Python will not support that. So now look at here. What are the things that I needed is Streamlit is the another one, and Streamlit option menu is another one. All those things we can put PYPI, the name you mentioned on the Google, you will have that. Okay, take copy that and paste it and install it. So like that, and then diabetes not SAV. Okay, so you have to keep everything in a single folder. That SAV file, the requirement file, as well as the diabetes public. That is the Python file. Everything should be on the same folder. Otherwise, you could put the error. So diabetes model.sav RB. So I'm mentioning here, and then again. So it is an option, selected option menu. The thing, what are the thing, system, what are the system that I'm going to create? It is diabetes disease prediction system, and then diabetes prediction. Okay, icons if you want to use means you can use some icons, and then index. Okay, and then if selected diabetes predictions, what are the uh, parameters dependent variables? That means first you give the columns, uh, column 1, column 2, column 3. Okay, to get the data. Okay, we are fixing as 3, and then the first column is number of pregnancies. So you can see from the code, pregnancies, glucose, blood pressure, skin thickness, all those things I'm just mentioning my. Okay, so number of pregnancy, glucose level, the font should be same, the case sensitive. Okay, everything you just keep it on mind, and then just BMI value, all those column 1, column 2, column 3, again column 1, column 2, column 3, and then column 1, column 2. That means it will be like this. column 1, column 2, column 3, column 1, column 2, column 3, column 1, column. I already worked on that. So that is the thing. And then diagnosis. You are creating one button for diagnosis, and then diabetes test result. Okay, based on the values of the pregnancies, glucose, blood pressure, skin thickness. Okay, if the prediction is 0, 1, the person is diabetics. Else, the person is non-diabetic. Okay, so anything is okay. Then just run it. If I run it, it is showing some warning. The warning is nothing but uh, the streamlet is trying to run with. We are running without the streamlet. I will tell you what is the streamlet. So that's the warning here. That doesn't cause any problem. Okay. If it shows some library function is missing, then try to install that library. Warning, you just leave it. Okay. So now this has been done. Save that in the same folder. And then the next step is you have to open the GitHub. So just you have to create one. So now I don't need this one because this is the model I have trained, and I'm going to use that model for already I have saved it in there, and that model I'm going to use for the deployment. Okay. So I'm just closing all things. I don't need that now. Now we are moving to the GitHub. So if you don't have the GitHub account, just open it because your Streamlit will directly connect that with the Git. The work becomes very easy. How to work on the GitHub is first you have to go to the Google GitHub, just create an account with that. I'll show here also it is closed. GitHub. So you have to create the account. Okay. So I'm just closing all the things. Okay. And then GitHub. So now first it will ask since it is there in my system, so I'm getting sign out. That is not signing out. So first you have to register the GitHub account, and then once you do that, you will have a screen like this. Here you have to create a repository files. So go to new and then create one name. Okay. So we are interested in any name. If you want to deployment, we are going to dip underscore ML. Okay. And then it is available, and then public, you keep it as public. Then only you can use that in the Streamlit. And then uploading an existing file. So already we have created the file. Just click that, choose your files. So this is the thing. I have stored everything there. Requirements also. So how to write this requirement file is, so that I want to explain you. Go to the Anaconda and go to the command prompt, open the terminal and pip list. Okay. Because if it is not there, then the requirement, it will show an error. So you can see the thing. So what are the requirements file I need is, first is NumPy. Okay. If you see the NumPy, where is N? So this is N. So what is the version of NumPy? 1.26.4. So I have to put 1.26.4 because with that only we have trained our model. So this thing you have to understand. After that, pickle mixing. Okay. So I have to see what is this version. So again, you go to the command prompt and see pickle mixin is there. So here is a pickle mixin I have installed 1.0.2. So I also mentioned 1.0.2. And Streamlit. So where is Streamlit? So that is the another thing. When you're running the program, we have installed all the library functions. You have to mention the same version. Otherwise, while implementation, it will put an error. To show an error, you cannot see the deployment. Okay, that's the one thing. Here you can see Streamlit option menu 0.3, 0.2. So I'm mentioning that. And then scikit-learn, Streamlit 1.32.2, and scikit-learn is, there is scikit-learn. So there is something where you have to identify. So scikit-learn, where is it? Oh, here it is. 1.4. Just mentioned. So these are the 5 library functions that is needed for the implementation deployment. So with the version, you just save it. Okay. So now upload everything on the things. So I'm just choosing the file, create and open it. Now my saved model, and then Python file. Okay. And then the requirements, everything will be there, and then give commit changes. Okay. Now it is in the sign up. Okay. When you sign up, while sign up, it will ask whether to connect with the email ID or connect with the GitHub. So since we have already created the GitHub with this mail ID, in the same mail ID, you create streamlit.io. So just type streamlit.io on your web. You will have a thing like that. That you just click, connect the Streamlit with the using GitHub. So that's why I'm creating the GitHub. From the GitHub, we can access our files. Okay, so I've done already. So you can see in my Streamlit, my GitHub integrated. Okay, so and then I've integrated my mail ID also. Yeah, both are we are using the same mail ID. So that is the reason behind creation of uh, creating a GitHub account. And then you have a create app. So I want to create the app. And then in that creating app, so there is lots of things in my GitHub. So I'm interested in the latest one, the ML. And then main branch. What is this main branch means? Where we store the document. So we have stored the document in the main. All these three files in the main. These three files are very, very important. Okay. And then the main path. So what is the main path? Main path is nothing but the Python file from the spider we have created. No. So that is the Python file. I'm just copy and pasting over there. Okay. When I paste it, it says domain name is available. So it is connected with them and deploy. When you give the deploy, it will take some time. Okay. And then you can see. Okay. Now you can see the name that I have given on my spider. Diabetes prediction system. Okay. So that is the option menu I'm given here. And then you have diabetes prediction. Okay. So if you want to add more system into it, sir, I want to include more machine learning model into this. Again, you convert every machine learning model into .sci file using the code, and then you just include that also. You can add more systems here. Okay. So here it is a diabetes system. Only one I have included. If you want to include many means, you just comma and then add more. Okay. And then here also corresponding to your model, you have to create the columns and then the name you have to give, and finally the diagnosis also you have to give. Okay, just copy and paste. Yeah, how many times you want, you can do it. And then I'm giving some values, the same values that we have trained, or you can give any other values. Okay, for analyzing purpose, I'm giving the thing. So I just close that. So what to do? I have to give by my own. Okay, and pregnancy is 6, it's a month, right? And then glucose level is around 80, and blood pressure level is around 70, sickness 45, insulin level 80, BMI percent is 69, degree is 3, age of the person 45. I'm giving for diabetes, and it says the person is diabetic. So you can send this link. Okay, copy this link. I am pasting that in some other browser. Just check it. I'm working or not. You can use as a app. You can use as a app. Okay, so this is a simple way of creating a deployment for the machine learning algorithm. Okay, so that's all about base class. So it's all about discussing. Okay, so we can do a lot of things like this. Okay, so because when you train the algorithm and you are seeing the data, it is not visible for the users. So if you want to make that available for the users, then you can use this Streamlit platform as well as GitHub, and with some modification on the code, you can just directly deploy. Okay, so now this is the end of the sessions for today. Close to that, you can see the faces is detected. Okay, it is a real-time capturing. If you give any other photos for that, again it will capture that. Okay, so that is one of the example. If I so I'll show the cell phone here. It detecting as cell phone. Am I right? And then by detecting my hands, it says person.